Right, we are going to get started in chapter 2, which kind of switches gears and we get into functions, which is similar to what we did with solving equations and inequalities in chapter 1, but we are a little more focused on some of the details of these equations. So a relation is a mapping or pairing of domain values with range values. Okay, the domain is the input, which is x. So think like when you're plugging numbers in an equation, usually you're plugging in the x value. The range is the output, which is the y value. So x values and y values. And then our example, given the mapping. So on the left is our input, on the right is the output, and I can see that we're missing this part of this number. This is a 2. So this is our x's, these are the y's, and they're paired up. So the relation would be our x, y order pairs. So like 3 gets paired up with -4. So it'll be 3, -4. That'll be the x, y. 1 gets paired up with -4. 1 also gets paired up with 7. And 2 gets paired up with 7. Okay, that would be our relation. All of the ordered pairs together make up your relation. Okay, and this mapping up here with the arrows shows how the x and y's are paired up. So the domain is going to be a list of the x values. So the domain would be 1, 2, and 3. That's the list of our values. And generally, we put them in order from least to greatest, but you don't have to. The range would be -4 and 7. So we have our domain, we have our range, and then they're paired up in that relation. All right, a function is a mapping where each input has exactly one output. So every input is only paired up with one output. So saying, is the example in number 1, is that a function? So if we look up, does every one of these x's only get paired up with one y? And you can see by the blue lines that for 1 is paired up with -4 and it's paired up with 7. So is that a function? No. And example 3 says, is this listed relation a function? So what I'm going to do is I'm going to make a mapping for this. I'm going to put my x's here, my y's over here, and I'm going to map them out. So the x's are 2, 3, 5, -3. My y's are 3, 6, and 0. So we got to draw the lines. So 2 is paired up with 3. 3 is paired up with 3. 5 is paired up with 6. And -3 is paired up with 0. So do any of these x's have 2 arrows where they go to 2 different numbers? And if you look, each of these x's only go to one number, so this would be a function. Because it's okay that, so if you're looking up here, you see that both of the 2 and the 3 both get paired up with the y value of 3. That's fine as long as one x doesn't go to 2 y's. So this one is a function as long as one x does not go to 2 y's. Like up above, you can see that there's an x value that goes to 2 different y values. Okay, a linear function is in the form y equals mx plus b. Okay, and it would look like this. Like we could say y equals 2x plus 7. You could really put any number in for m and b. And that's what we're going to deal with next. The coordinate plane is broken into 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. Okay, and it goes counterclockwise. In quadrant 1, I'm going to put a plus plus. Quadrant 2 is minus plus. Quadrant 3 is minus minus, and quadrant 4 is plus minus. That's for the x's and y's. So in quadrant 1, both x and y are positive. In quadrant 2, it's to the left, so x is negative, and it goes up, so y is positive. Quadrant 3, they're both negative because it's to the left and down. Quadrant 4, x is positive because it goes right. Y is negative because it goes down. So that's just talking about if it's positive or negative for x or y. Okay, example 4, we're going to graph the relation and decide whether the relation is a function. So if we graph it, the first one, x is 2, y is 3. So we go to the right 2, then up 3. The second one, x is 2, y is negative 1. To the right 2, down 1. The next one is x is 3, y is 0. And then x is 4, then x is 1, y is 2. So your ordered pairs will look like that. And then it says, decide whether the relation is a function. So do any x values get paired up with 2 different y values? So if you look, x is 2 gets paired up with 3. And if x is 2, it's also paired up with negative 1. So you see how one x value, 2, the same x value has 2 different y values. So the answer is it a function? No. X equals 2 has 2 y values. A vertical line test. A relation is a function if no vertical line intersects the graph at more than 1 point. So if I draw a vertical line throughout this graph, will this vertical line ever cross 2 points? Yes. You see that green line? That green line crosses 2 points. So a function is a function if no vertical line intersects the graph more than 1 point. So you see the green line, it crosses 2 blue points, so this is not a function. And here's how we use the vertical line test. So example 5, if we do a bunch of vertical lines, will that blue graph ever cross more than once? It will not. So is this a function? Yes, because it passes the vertical line test. In the second one, do you see how a vertical line will cross through more than one spot? So this one is no, it's not a function because it does not pass the vertical line test. Okay. Function notation, which is kind of new, I think, in Algebra 2, or somewhat new from what you saw in Algebra 1. Function notation is written like this. Okay, and you would read this, f of x. Or you could write it like this too, this is common. This would be read g of x. And then just a little note, f of x means the same as saying y. It's used the same exact way as saying y equals mx plus b, except for we say f of x. And that's kind of like a way to name a function. So like in example 6, says evaluate each function for the given values. So f of x equals 5x plus 7 when x equals 4. So what you're going to do is you're going to take your function and you're going to put 4 in for x. So we're going to input or put in 4. That's why we call the x's inputs. So it'd be f of 4 equals 5 times 4 plus 7. So f of 4 is equal to 20 plus 7. So f of 4 is 27. So just so you're aware, this is kind of like saying y equals 5x plus 7 and plugging 4 in for y. You would get y equals 27. So it is the same thing, except for function notation calls it f of x. And there's a lot of reasons why we have function notation. In this class, we're going to have sometimes we have multiple graphs we're talking about or multiple equations. And this is how we can identify the different equations. We call them f of x or g of x or h of x. So we plug it in and we get 27. So basically x is 4 and y is 27. Our input and our output. Okay, graphing a function. So what we're going to do when we graph a function is solve for y, then make a table. Okay, so number one, we have y by itself. So this is basically like saying f of x equals negative 2x plus 1. So we're going to plug in our x's, and we're going to find out what our output is. We're going to find out the y. So thinking of what we just did, we're going to plug in negative 1. So it's going to be f of negative 1 equals negative 2 times negative 1 plus 1. So when you plug in negative 1, what do you get? 3. Okay, what about when you plug in, let's do negative 1, let's do 0, and let's do 2, and we'll see what we get. So f of 0 equals negative 2 times 0 plus 1. You would get 1. And f of 2 equals negative 2 times 2 plus 1. You would get negative 3. So you're plugging in the x's, you're getting out the y's. So you graph them, negative 1, 3, 0, 1, and then 2, negative 3. So that's what your graph would look like. And if you connect the dots, it would form a line. All right, and that's what we got to start functions.